All right, so number 10, we're going to draw a free body diagram of this box. With some kind of applied force and a friction force. It is moving, so I will actually label this as kinetic friction. Now, we're going to determine the pushing force by setting up the unbalanced force equation horizontally. So Fa minus the force of friction equals m, which is 15, times A, which is 2. Let's go ahead and calculate that friction force. And that's going to be mu kinetic times the normal force, which will be 0.2. And now let's get that normal force by balancing vertical components. So Fn minus Fg equals 0. And that tells us that the normal force is 150 kilograms. All right, so that's 0.2 times 150, which gives me a 30 Newton force. So Fa minus 30 equals 30. And that's going to give us an applied force, which is the force the girl pushes with, equal to 60 newtons. Now let's figure out what happens if she pushes with 1 newton of force. So we still have the applied force minus the friction equals m times A. But we're pushing with 60. We don't know this friction. And we're taking a 15 kilogram block and accelerating it at 1 meter per second squared. So this is going to give us a friction force of 45 newtons. And now we ask what the coefficient of friction is. So we know the force of friction is going to equal mu kinetic times the normal force. In this case, it's going to be 45 is mu k times our normal force, which is 150. And when we actually work that out, it's going to end up being 0.3 equals mu k. Next, we want the speed of the box after the 3 seconds, assuming it starts from rest. So we're going to say v equals at plus v naught. That's v equals 3 times 1 plus 0, which is 3 meters per second. Next, for this last part, we're going to let go of the box. We're going to calculate what happens after that. So we have that the force. Now let's just draw the free body diagram first of all. So we're going to have this friction force going to the left, normal force and gravity. So here's the thing. We only have the friction force making the box accelerate. So that's going to be negative 45 equals 15 times A. So A will be negative 3 meters per second squared. And we can use this to get the time it takes to rest if we're going at 3 meters per second. So V equals AT plus V naught. We end up at 0 with an acceleration of 3 meters per second squared times an unknown time. And we start at 3 meters per second. So that gives us a time of 1 second. All right, so that is the next page.